Given 1 minus I alpha upon 1 plus I alpha is equal to A plus IB, then A square plus B square is equal to A plus IB is equal to 1 minus I alpha divided by 1 plus I alpha. And now apply conjugate on both the sides. And we know that Z1 by Z2 conjugate is equal to Z1 bar upon Z2 bar. So we can write here A minus IB, which is equal to 1 minus I alpha upon 1 plus I alpha bar. That is A minus IB is equal to 1 plus I alpha divided by 1 minus I alpha. Since we know that if Z is equal to A plus IB, then Z bar is equal to A minus IB. And now let us multiply both A plus IB into A minus IB, which is equal to 1 minus I alpha divided by 1 plus I alpha into 1 plus I alpha divided by 1 minus I alpha. So we can write as 1. A plus IB into A minus IB is A square, and here we can write I square is negative 1, so minus 1 into B square is equal to 1, that is A square plus B square is equal to 1. You can remember A plus IB into A minus IB is equal to A square plus B square. So we can go with an option A. Given that x square minus 11x plus A and x square minus 14x plus 2A, and both are having a common factor, for A is not equals to 0, then what is its common factor? Let us consider x minus alpha be the common factor. So which implies then x is equal to alpha will be the solution for the equation. X is equal to alpha is the solution for both the equations, that is x square minus 11x plus A is equal to 0 and x square minus 14x plus 2A is equal to 0. So we can simplify here. Alpha square minus 11 alpha plus A is equal to 0 and alpha square minus 14 alpha plus 2A is equal to 0. By solving these both, we'll get by subtracting. So we'll be getting here minus 11 plus 14, that is 3 alpha, and again here minus A is equal to 0, so which implies alpha is equal to A upon 3. So let us substitute alpha is equal to A upon 3 in one equation. So we get, so that is alpha square minus 11 alpha plus A is equal to 0. So A square by 9 minus 11 into A by 3 plus A is equal to 0. So A can be taken common. So A upon 9 minus 11 by 3 plus 1 is equal to 0. So A times of, so we can take A minus 11 3s are 33 plus 9 is equal to 0. So A into A minus 33 minus 9 will get 20. So this is 24, 33 minus 9 will get here 24. So we can say either A is equal to 0 or A is equal to 24. But it is given that A is not equals to 0, so this cannot be considered. So we may consider A is equal to 24. So when substitute A is equal to 24 in one of the equation, so we get here x square minus 11x plus A, that is 24, is equal to 0. Factorization if we do it, x square minus 8x minus 3x plus 24 is equal to 0. So x times of x minus 8 minus 3 times of x minus 8 is equal to 0. So x is equal to 8 and x is equal to 3. And let us substitute x is equal to 3 in the second equation. So here we can find 3 square 9 minus 14 threes are 14 threes are will get here 10 threes are 30 plus 42. 42 plus 2 times of a, that is 48. We can say which is not equal to 0. So x is equal to 3 is not the root, and when you substitute x is equal to 8, so you'll get 8 8s are 64 minus 14 times 8, 80 plus 32 112, and again plus 2 into 24 is 48. So 64 plus 48 is, we can say 112 minus 112 is 0. So we can consider x is equal to 8 is the solution, or we can write x minus 8 is a common factor. So we can go with an option C. Given an equation 1 upon x plus a minus 1 upon x plus b, which is equal to 1 upon x plus c, the product of the roots is 0, then the sum of the roots is. So on simplifying, we can write x plus b minus of x plus a upon x plus a into x plus b is equal to 1 upon x plus c, or we can write b minus a into x plus c is equal to x plus a into x plus b. Let us simplify here. X times of b minus a plus c times of b minus a is equal to x square plus a plus b of x plus ab. This can also be written x square plus, and here x coefficient is a plus b and here it is b minus a. So we can write here x times of a plus b minus b plus a, and again minus or plus ab minus c times of b minus a is equal to 0. Or we can write x square plus x times of 2a plus ab plus ac minus bc is equal to 0. So we got a quadratic equation, and here we can say it is given that the product of the roots is 0. So product of the roots is c by a, that is for quadratic equation ax square plus bx plus c is equal to 0. The product can be taken as product of the roots is c upon a. So we can write AB plus AC minus BC is equal to 0, or we can also consider A times of B plus C is equal to BC, or we can say A is equal to BC upon B plus C. And also the sum of the roots is minus B by A. So we can say the sum of the roots, which is equal to 2A minus 2A, that is minus 2 into A value is BC upon B plus C. So minus 2bc upon b plus c is the answer. So which is option D. Given alpha and beta are the roots of the equation ax square plus bx plus c is equal to 0. Here the roots are alpha and beta. And now the equation ax square plus b into x plus 1 plus c times of x plus 1 whole square is equal to 0. So let us divide with x plus 1 whole square on both the sides. So we can write a into x upon x plus 1 whole square plus b into x upon x plus 1 plus c is equal to 0. So let us consider x, or we can write let capital X is equal to x upon x plus 1. So which implies a into capital X square plus b into capital X plus c is equal to 0, which is almost like similar to this equation where alpha and beta are the roots. So that is x is equal to alpha or x is equal to beta. So let us consider, we can write x upon x plus 1 is equal to alpha, or x is equal to alpha x plus alpha, or x times of 1 minus alpha is equal to alpha, which implies x is equal to alpha upon 1 minus alpha. Similarly, we can write x is equal to beta upon 1 minus beta. So alpha upon 1 minus alpha, beta upon 1 minus beta are the roots of the equation. So we can go with an option D. Given a real part of a complex number z bar plus 2 upon z bar minus 1 is equal to 4, where z is not equals to 1, then the locus of this point z representing in the complex plane among the four options we need to check. And we know that whenever x is z is equal to x plus iy, a complex number, and z bar will be taken as x minus iy, so that we will be getting, by adding these both, z plus z bar will get 2 times the x, that is real part of z. That is 2 times real part of z. So here also we can write real part of this complex number, we can write it as z plus, or we can say real part of z is equal to 1 by 2 of z plus z bar. Let us use the same concept here. Z bar plus 2 upon z bar minus 1 plus conjugate of this, we can write z bar plus 2 divided by z bar minus 1 whole conjugate is equal to, or 2 times, or 1 by 2 times, you can write here 2 times 4, 8. So this can be written as z bar plus 2 upon z bar minus 1 plus, and here we can write z plus 2 conjugate of 2 will be same 2 only, real number, and here z bar is z minus 1 is equal to 8. Let us simplify this. Z minus 1 into z bar plus 2 plus z plus 2 into z bar minus 1 is equal to 8 times of z minus 1 into z bar minus 1. So which implies here z into z bar minus z bar plus 2z minus 2 plus z into z bar plus 2 times of z bar minus z, and again minus 2, which is equal to 8 times z into z bar minus z bar, and again minus z plus 1. Upon simplifying, we get 6 times z into z bar minus 9 times z minus 9 times z bar plus 12 is equal to 0. We can also write z into z bar minus 9 by 6 times of z minus 9 by 6 z bar plus 12 upon 6 is 2 is equal to 0. So this can also be written z bar minus 3 table 3 by 2 z, or plus of minus 3 by 2 z, or plus of minus 3 by 2 into z bar plus 2 is equal to 0, which is in the form z into z bar plus a into, or a bar into z plus a into z bar plus b is equal to 0. This equation represents a circle with a center. Here a is a complex number. With a center we can consider as negative a, and the radius of the circle is under root of mod a square minus b. So when comparing, we can consider the center of the circle is negative a, which is equal to negative of negative, that is 3 upon 2, and radius is equal to under root of mod a square. So we can write 3 by 2 whole square is 9 by 4 minus b value is 2. So that is under root of 9 minus 8, 1 upon 4, which is 1 by 2. So the radius is 1 by 2 and the center is 3 by 2, which is the real number. So which also means to say that this is center point can be taken as 3 by 2 comma 0. So we can conclude with the option, it's a circle with radius 1 by 2, option D. Given for a quadratic equation ax square plus bx plus c is equal to 0 has two negative roots for abc belongs to real numbers. So it has two roots alpha and beta, both are negative. Alpha less than 0, beta less than 0, which implies sum of the roots is negative and product of the roots is positive. So sum of the roots from here we can write minus b upon a is negative and product of the roots c upon a is positive. So minus b upon a is negative, which implies b upon a is positive. So in this two cases arises either b positive, a positive, or b is negative, a is negative. And in this case c upon a is positive, so either c is positive, a is positive, or c is negative, a is negative. So now when a is positive, considered c is positive here, a is positive. When a is positive means we can go with a b positive. So we can just conclude when a is positive, b is positive, and then c is also positive. All are positive, are of the same sign, we can all are positive. And in the case of a negative, when a is negative, and here a negative, in the case b negative. So when a is negative here, then b is negative, then c is also negative. So in these both cases we can just confirm that the two roots are negative roots. So a, b and c either positive or negative, or we can say that they are all of same sign. We can conclude that a, b, c are of same sign. So we can go with an option A. Given mod of z1 by z2 is equal to 1, which implies that mod z1 upon mod z2 is equal to 1, that is mod z1 is equal to mod z2. So let us consider both are equal to magnitude is r, and also given argument of z1 z2 is equal to 0. So according to the property, argument of z1 z2 can be taken as argument of z1 plus argument of z2 is equal to 0, that is argument of z1 is equal to negative of argument of z2. Or if argument of let us consider argument of z1 is equal to theta, so which implies argument of z2 can be taken as negative theta. So let us consider z is equal to z1 is equal to r into cos theta 1 or theta plus I sin theta, and z2 can be taken as r into cos of negative theta plus I sin of negative theta, that is r of cos of negative theta is cos theta minus I sin theta. Cos theta minus I sin theta is nothing but it's a z1 bar we can write. So z2 is equal to, we can consider z1 bar, and now mod of z2 square consider mod of z2 square, which is equal to z2 into z2 bar. According to the property, mod z square is equal to z into z bar, so we can write z2 into z2 bar. So z2 is nothing but z1 bar into z2 bar, which is nothing but z1 z2 whole bar, or we can also write Z2 bar is nothing but Z1. Z2 bar is nothing but Z1, or Z1 bar is equal to Z2. So this can also be written as Z1 into Z2. So mod Z2 square is equal to Z1 Z2, which is option B. We can go with an option B. Given a complex number Z is equal to 3 minus I upon 2 plus I plus 3 plus I upon 2 minus I, then we need to find the argument of Zi. So let us simplify this. So we can write 3 minus I into 2 minus I plus 3 plus I into 2 plus I divided by 2 plus I into 2 minus I, which is equal to 3 2s are 6 minus 2I minus 3I plus I square, and again here 3 2s are 6 plus 2I plus 3I and again plus I square divided by 2 2s are 4 minus I square. So we can simplify and write here 6 plus 6 12, and minus 2I minus 3I is minus 5, and again here gets cancelled. So I square is negative 1 and I square is negative 1. So negative 1 is negative 2 divided by 4, and I square is negative 1, so we can write plus 1. So that is 10 upon 5, which is equal to 2. So we got Z is equal to 2, and then Zi is equal to 2I, which can be written as 0 plus 2I. So it's a point 0 comma 2 on positive direction of y-axis 0 comma 2, and here we can say that from x-axis the angle which makes is 90 degrees, because x-axis y-axis both are perpendicular, and the point 0 comma 2 is located on y-axis. So we can consider argument of Zi is equal to pi by 2. So we can go with an option D. We need to find the value of cos theta plus I sin theta whole power 4 upon cos theta minus I sin theta whole to the power 3. We know that cis theta, that is cos theta plus I sin theta, is equal to e to the power I theta, and cos theta minus I sin theta, which is equal to e to the power minus I theta, that is cis of minus theta. Since cos of negative theta is cos theta, so we can write e to the power negative theta, and let us apply here cos theta plus I sin theta, that is e to the power of I theta whole power 4 divided by e to the power minus I theta whole to the power 3, which is e to the power of I 4 times theta by e to the power of I minus 3 theta. So which can be written as e to the power of I 4 theta plus I into 3 theta, that is e to the power of I 7 theta. So this can also be written e to the power of I theta whole power 7, that is cos theta plus I sin theta whole power 7, or this can also be written directly here cos 7 theta plus I sin 7 theta. So we can go with an option B. We can also remember one property, cos theta plus I sin theta whole to the power n is equal to cos n theta plus I sin n theta, and 1 upon cos theta plus I sin theta is equal to cos theta minus I sin theta. By using these two properties also we can expand it. So the answer is option B. So given equation, x square plus 2 times of k plus 1 of x plus 9k minus 5 is equal to 0 has only negative roots. So since the equation is having negative roots, which implies that the discriminant is greater than or equals to 0. This is the first condition. And the second condition, since both are negative, if alpha and beta are the roots, so alpha beta is negative, so alpha beta must be positive. So which implies that 9k minus 5 divided by 1 is greater than 0. And the next third condition, and sum of the roots, that is minus b by a, so minus 2 times of k plus 1 upon 1 must be negative. Since we know that for the quadratic equation ax square plus bx plus c equals to 0, so sum of the roots and product of the roots is given by, so sum of the roots is minus b upon a and product of the roots is c upon a. So delta is, discriminant is b square minus 4ac. So let us simplify here, which implies 2 times of k plus 1 whole square minus 4 times of 1 into 9k minus 5 is greater than or equals to 0. So which implies that 4 times of k square plus 2k plus 1 minus of 9k minus 5, so whole taken common, greater than or equals to 0, or we can simplify k square plus 2k plus 1 minus 9k plus 5 is greater than or equals to 0. So k square minus 7k plus 6 is greater than or equals to 0. By simplifying, we can write k square minus 6k minus k plus 6 is greater than or equals to 0. So k taken common, k minus 6 minus 1 taken common, k minus 6 is greater than or equals to 0. So k minus 6 into k minus 1 is greater than or equals to 0. By wavy curve method, we can say for k is equal to 1 and k is equal to 6, since it is positive, so we can consider k belongs to minus infinity to 1 union 6 to infinity. So this is the condition 1. And coming to the second condition, so we can write 9k minus 5 is greater than 0. So k is greater than 5 by 9. So this is the second condition. And the last condition, alpha plus beta is negative. So we can write minus 2 times of k plus 1 is negative. Or we can write k plus 1 is greater than 0. K is greater than minus 1. So this is the third condition. So from 1, 2 and 3, k is greater than minus 1. So we can consider, say minus 1 is here and 5 upon 9 and then 1 and then again 6. So from 1 we have above 6 and below 1, and from second one we can say more than 5 by 9, and from third one we can say it is more than minus 1. So it is greater than minus 1, so we can simplify and we can see that all the three graphs we can observe it k is greater than or equals to 6. So we can conclude that from here k must be greater than or equals to 6. So which is option C.